All right, it's top of the hour. Happy Thursday, everyone. Welcome to IoTSF, which is IoT Security Foundation Houston's monthly webinar. A little introduction about IoTSF itself. IoTSF Houston is a authoritative source of expertise, knowledge, and guidance for IoT security here in our greater Houston area. We are a new organization, and we are looking for collaboration and support from our members and our community. So if you're interested in joining us or volunteering or becoming part of our chapter, please do reach us out. I'll put some information on the chat later. So today, is a IoTSF webinar. This is our monthly webinar. I would like to introduce you to our speaker, who is Aaron Alsbrook. He's the co-founder and CTO of ClearBlade. It's an Internet of Things IoT company with edge computing and AI software. ClearBlade delivers its award-winning IoT edge computing and intelligent assets SaaS offerings via Google Cloud Marketplace. Early on, Aaron engineered software at IBM, building scalable, performant platforms for developers to design, develop, and execute modern workloads. As a practitioner, Aaron worked directly in the field with enterprise to enable cutting-edge solutions while leveraging existing technical assets. Today, he is here to help us understand the key principles for introducing IoT and edge processing into our OT environments. We will also look at strategies and learn about principles to address threats from physical access, hardware layers, legacy and modern protocols, which is local wireless networks, server-side infrastructure, and more with him today. So without any further ado, I give you Aaron. Aaron.
Oh, wow, pleasure. Thank you so much for the introduction, and certainly appreciate the chance to speak to everyone here at the Security Foundation. What an important topic, and what a topic that unfortunately is often left till the end of the process before anyone starts really thinking about it. So I'm really grateful for everyone here today and those who are taking this seriously. My name is Aaron. I'm Aaron Alsbrook. I am with a company called ClearBlade. Our topic today is securely achieving IoT value in OT and SCADA networks. What a huge mouthful. I don't think we can really do this deep justice. You guys are probably in the audience here. Some of you probably have tremendous depth in this topic already and know that there's lots and lots that can be done. As you peel this onion, you go into the Purdue models, all the different things. But we are going to take a look at it today, and we're going to see how we can at least approach this from a big picture and kind of break it down and what lessons can we learn. So that's our goal today. I'm going to start with just an introduction. Again, not trying to make a commercial here, but just so you know where I'm coming from. ClearBlade is a software company. We have customers all around the world. We're focused on several verticals. Specifically the industrial verticals like transportation, utilities and energy, buildings, facilities, and manufacturing. If you look at all the little dots on here, you can notice there's certainly a lot we're doing in the greater Houston area. Just a little bit northwest of you in the central Austin area, but in Houston all the time. And certainly love to be part of that ecosystem. You guys have some amazing projects going on with different things you're doing. Obviously a hotbed for energy, so to speak. So a lot of what we're doing is in that energy space. I'll call out a couple things here. Obviously, we have many devices. We have over 6 million devices under, say, management, so to speak, by our software. That would be one thing if it was kind of a little home device. But when you're talking about industrial devices, this is 6 million things have been screwed into industrial places. So a lot of effort has gone in by different companies, customers, partners of ours to deliver this IoT software and Internet of Things edge software. Some of our customers are some oil field services folks. So, be aware we are actively working in that space. making sure that we're helping with the drilling processes, the pipeline processes, helping with the upstream and downstream. Lots that can be done there when it comes to unlocking the data in those environments. We're also with lots of utilities, both municipal and government utilities and private utilities. We do lots of basically other services companies for managing controls. All sorts of use cases are being done in just these four verticals, which is just fascinating to us of what you can do and what you can achieve ROI wise. Great background. I appreciate the introduction. So I'll be really quick here just so you know where I'm coming from. My background was computer and electrical engineering. So I guess you could say thought I was going to be an OT guy. I thought I was going to be in the field, putting together hardware. I learned a ton. That's my background out of school. And the first thing I did was I went into the software space. So I quickly changed my coat and became an IT person for a bit of a time. Trying to help modernize workloads, again, moving things to distributed computing, getting things to the Web 2.0. You remember all that phase. I did not only as a software architect and a software developer, but I also did as a consultant. So all those great ideas we had in the lab, how do we use them in practice? That's where I really learned about how do we put this stuff to work. Joining Clearblade, founding Clearblade with my co-founder, Eric Simoni, over almost 15 years ago now. I was the chief architect for our IoT platform. That's what we called it back then. They were still IoT platforms. They weren't necessarily just cloud services. And the chief architect of our Edge platform. These are both critical when you talk about how are you going to work with the OT infrastructure. That Edge is how are we going to get into that environment. So chief architect of those products. And meanwhile, today, most of my time is spent putting these products securely at work, delivering value. When it comes to security, I do represent our lead for our compliance processes, both SOC 2 Type 2 and ISO 27000, latest 2022 version. We have other frameworks you can imagine that we're involved in, but it's important to know that I am a consumer of these things like many of you. So I'm not an auditor, so to speak. I'm on the other side with the realities of how do you implement these things? How do you make sure you're doing not only what there might be the checkbox, but the spirit of what we're trying to accomplish and why do these things exist? So that's where I live in the overall ecosystem of securing what are industrial assets, operational assets, SCADA-like network data feeds, as they become unlocked. So that's my background. Again, I'm really excited by this topic, although this topic is usually something people think of as an afterthought. I think we have to get this right. We have the Cybersecurity Agency, Infrastructure Agency. I think that's an incredibly important one. CISA, try to work close not only with our partners and private industry, but also our government focused industries as well. So that's Clearblade. That's why we care. That's my background. That's why I care. So I thought our agenda today would be kind of simple. We would take it kind of like a security process where we just kind of look through risks and treatments. If you've ever done one of these audit frameworks, you know that identifying your risks, putting treatments in place is how you really can improve your security posture. So I'm going to talk architecturally only. I'm not going to try to go put new cool processes in place. That's for another time and place. But we'll talk about the risks within an architecture. I'll pick IoT first. I think it's easy for all of us to see IoT. We know it because we all have things at home that are starting to get connected, whether it's our car or our television or our refrigerator. So it puts the practices, the principles in place. I also think in some ways it's a worse ecosystem to try to work in. So I'll contrast that IoT environment after we go through it with the OT environment that most of us will ultimately be trying to connect. And then we'll bring those worlds together. We'll talk about some bad practices, but we'll talk about what it can do when it can come together. We'll even kind of go through how can you iteratively get there. Sometimes it's tough to jump to the end of the story. So if you're taking intermediate spots, how do you still even do that with a good security posture? So that's the overview. Then we'll end with some cool examples, some things that people have unlocked those SCADA systems, the value they're achieving. Again, if there's no reason for this, then it's kind of silly to spend the time. So we'll dive into that. And then if we have the time, I'll open it up for Q&A. Hopefully there's a few of you out there who are interested and can drive some good conversations. Hopefully I have some good answers to share. With that, let's dive in and talk about what is an IoT architecture. So let's just imagine the simplest device you may have. Let's just pick a little water meter or something you may have. That device is on the far left here on the screen. And ultimately, it's going to communicate. It typically communicates over something called a broker. Maybe some of that data gets put into a cool database, and then there's some sort of app that lets us see what's happening, maybe even interact with that water sensor that might be out in the field. That's a basic architecture. And so when you look at this would probably live over a public network. Maybe it's cellular, home Wi-Fi. But if you start to break that down, you really realize there are parts of this ecosystem that you completely trust. The part in the middle, the software, you trust it. The parts on the left and right, honestly, the most important parts are both untrusted. You really can't trust that device. You really can't trust that end user. You don't know who they are. You don't know if they're going to be a positive influence or a negative influence. So really, when you talk about zero trust networks, you can see where that comes from, because you really just have to say, I can't trust anyone. In a zero trust, we really wouldn't even trust internally between the pieces of software. They all still interact. But for an IoT example, right now we'll think about the device is untrusted and the end user is untrusted. And so how do we establish trust in that environment? Why is it a problem that we don't trust it? I mean, what are the pieces we don't trust? We don't trust the manufacturer. We may have great partnerships with our distributor or our manufacturer out of Asia, whoever it may come from. But when it's all said and done, they're probably outsourcing into other factories. So we can't really believe that they're going to put down the absolute software that we trust, untrusted. The fact that it's going to sit in someone's home means that we have to expect someone to unscrew the top, go in there and play with things. There is no physical security. There's no gate or fence like we would have at a railroad crossing with an alarm that goes off, or in a building. Physical security is out the window. And then that network, we have to assume we're sitting on a network with lots of other devices that are hostile. They're sniffing what's going on. They're trying to see what's happening. So from the device side, we have the worst case scenario. How do we get a trusted connection when we trust nothing that we're sitting on? On the other side, similar problem. That network is sitting out there. And then unfortunately, in a lot of products, we want to let every user in possible. Self-service, you sign up, you get the data right away. So those users, though, are not always positive users. Sometimes they're going to be interested. I wonder if I can see what's going on in the data. Wonder if I can make calls and get data that I'm not supposed to see. This is what's going on in an IoT architecture today. We have to deal with the conditions of basically a completely untrusted client on either side. Why do we care? Well, if we have data that matters, we really want to make sure people can't intercept the data. We don't want people to see it. If we're letting devices in, we want devices to follow the rules. You can't over-authoritize a device because it can be spoofed. So it could do things that you don't want to allow it to do, meaning it could interact with other people's devices. It could force data to other users. You want to prevent device spoofing. And then you really overall want to prevent people from interacting and misbehaving. So a device shouldn't be able to turn on and off if that's not in the use case. So you really have to protect what could be done by these devices on the left-hand side. I'm sort of going to ignore the right-hand side. I think we all agree we have lots of practices for how we lock down computers and establish two-factor auth on these users on the right-hand side. But I am going to focus on the left-hand side. That's where our IoT exists with these devices. So when we talk about this ecosystem, the first thing we do is say, how can we build trust into this untrusted environment. And that's where we look at some basic principles, that we call out. IoT, for all intents and purposes, and security especially, is something that continues to evolve. This list is 2 items longer than it was 7 years ago when I first made it. So this is not the forever list. This is the list right now we use to establish trust, and it will grow. But some of this stuff will become so obvious that it's easier for us to onboard new capabilities. But let's go through these. The first is, if we don't want people to be able to see the data across the wire, we use encryption. Good news, we know how to do this very well. As a matter of fact, we've gotten pretty good at doing it easily. 10 years ago, trying to figure out how to put a certificate on your server meant a lot of complex work on your part of kind of DevOps behaviors, and certainly for your clients to connect with an encryption algorithms, it meant that you were having to put custom libraries in that were all kind of new at the time. That today is pretty standard. We know how to make sure we have a trusted browser. For a while, we wanted to make sure everybody used HTTPS across the top. That little S portion exists not only in your web browser, but it exists across every IP connection that you could have in there, TCP/IP connection. So we want to make sure that we put encryption in. There is a challenge, is that these things are changing. Notice that if the algorithm is changing, it's going to require the device to do the new algorithm, the better algorithm, the longer hash, but it's also going to require us to do updates. I'll call that out because those are 2 of the variables we have to make sure we're addressing, the updates for what's going on to deal with future best practices. The second thing that's important that we do to establish trust is we put in a provisioning process. What that means is because we can't particularly trust that manufacturer and what that software might be when it leaves the factory, we need to be able to put in a provisioning process to ultimately add that trust, so the end user can provide that secondary trust, that 2-factor trust, to say, okay, this device is allowed to come in and behave on my behalf. It's allowed to be my refrigerator. So a provisioning process is key. We also look in authentication. We all are very familiar with authenticating as users. As a matter of fact, we probably are overly familiar with it. I have 4 2-factor apps on my phone now, depending upon where I'm logging in. I use this 2-factor, this secondary key. In the olden days, we might have had the RSA little USB drives. Ultimately, authenticating, the user providing a credential and even secondary credentials to be sure you are who you say you are. The 4th principle, establishing trust, authorization. Authorization means, okay, I know who this person is. I know who this device is, but now what are they actually allowed to do? Role-based authorizations we see very often. If you manage the cloud security, you'll certainly see different policies of groups of putting people in roles or devices in roles, service accounts in roles. This is important, especially in IoT, because authorization allows you to limit that one device can't talk to another device or change another device, or one device can accidentally go and send data and impact an activity that a device shouldn't be able to do. It can't go and delete a whole bunch of other devices. So ultimately, authorization, authentication, encryption are almost the fundamentals. Provisioning is something that really comes online as part of how we add trust into the overall system during onboarding. And then the last is audit. I wish I could tell you that audit was something that you don't particularly need, but these things are always changing. Knowing what's going on in your system, knowing the new threats that appear, knowing how to react to things is all done with the good audit trail. Audit trails are tough because with IoT, it is a huge amount of data. Personally, I find that there are many IoT systems that look bigger in terms of communication and data flying around and data rates than things like Twitter. Twitter have kind of end user bounded to them, so that you end up with not so much data, maybe lots of reading and stuff downstream, but less data, or less maybe interactions are going on in that environment, versus an IoT system where you have hundreds of thousands of data potentially spewing information every second. it is a challenge to keep an audit trail that is meaningful without having so much data you don't know what to do. I'll pause here and I'll go back in time. Something I said back when this list only had 3 bullets, I was giving a security kind of overview in IoT. And the real principle of it was security is like, IoT especially is like being chased by bears. You're never done. The bear is still after you. The bear means that you ultimately have to keep getting better. You have to keep improving your encryption. You have to add more layers of trust into your provisioning. You have to tighten your authorization. You have to review all of this all the time. You must be running faster, quite frankly, than others around you, because they will always being tested in our ecosystem. So I love this. We'll kind of run the bear metaphor, the bear theme through this of a conversation of making sure that we are in a position where we can continue to get better, continue to put more trust in these zero trust like environments. So how do we do that? Thinking back to that IoT architecture, again, Clearblade is the product that we use. So I'll just put that in the middle. But ultimately, how are we going to build the trust around the device to our IoT solution, to our end users? Well, the first thing now is we will look at that firmware, and we will do things like make sure that we have the ability to update it. And then we will also make sure that we build a provisioning lifecycle into that firmware, so we can have a untrusted initial release of the firmware. As it's provisioned, we now establish that trust into that device, and we let it in and we let it communicate. So lots to dive into in a provisioning lifecycle, but in a perfect world, your installer might go out there, put the device down. It's a generic device that just got shipped to you from Thailand or wherever it came from. Your installer scans a QR code, whatever that may be. That little action is the provisioning. It makes that device move over from being generic to yours, to talking to your solution. That's the first strategy, addressing that a base step out of the gate. The next thing is we're going to make sure we're transporting over TLS. That just means the encryption algorithm. TLS 1.3, I believe, is the latest. 1.2 is considered still a best practice. Anything below that now, it's getting to be a bit things that can be basically cracked at scale. So we want to have a higher level of TLS. Again, I call that out because that first bullet of OTA, over the air updates, is important if we're going to be able to keep moving up that encryption algorithm over time. So we're beginning to address this. We then also look at authentication. There's a number of patterns in the IoT ecosystem. I won't call them all out right now, but essentially different ways that device can present a credential. In the case of a user, it'd be username and password, but devices don't really remember usernames and passwords. So different ways that you can essentially put down keys that never go over the wire. So have keys created on the device at provisioning time, and then send a token associated with it, and then have it securely authenticate. That is key to basically establishing trusted authentication that can't be spoofed or stolen by others. We then look at how can we protect ourselves. We have the authorization, so we put device roles in place. In the MQTT world, if you're familiar with that protocol, you can actually build the application itself can protect topics, so you can make sure certain devices can only talk to their topics. All of that helps define authorization. And then we have to protect ourselves. We have throttles that we build in. So how can we make sure that a device, if it is compromised, maybe we didn't do one of those other things very well as a solution developer, how do we have the ability to cut it off, whether it's the rate, the origin, how we see it behaving? We have to put those throttles in place. And finally, we build the audit log. All this stuff's coming in, pumping these logs externally, so getting them out of the system, putting them in places where our security folks can monitor them so that we can look at them in offline times, put and build metrics around things over these logs. All of this gets done as well in an IoT solution. Finally, we do this for users as well. This is not something that's unique or different because it's IoT. We would do this in any solution. You may have solutions like Atlassian or Salesforce or whatever it may be, Office 365. These are the kinds of things that those tools are already doing, but we're bringing them into the overall IoT ecosystem. So that is what we're trying to do when we try to secure IoT. You would think that would be enough if we could just do that, but OT is coming from a different starting point. IoT in the home is basically coming from a brand new device, probably on a home Wi-Fi. IoT often is a whole different way of looking at the world compared to what we might want to do with OT or in our SCADA environments today, SCADA infrastructures. In many ways, what we're accomplishing with OT and SCADA today is pretty amazing. We act like it's really cool to be able to turn on and off or unlock our doors, but man, we've been doing that, monitoring that kind of stuff for a long time in our operational environments. So why in the world would we even change? Why would we start looking at some of this IoT capability, this fully remote capability when we've had this stuff? Well, often the environments that we've had have had very limited backhaul. Sometimes we had no connectivity. So while there might be a system out in the field, an operational SCADA system controlling things, we've never unlocked that data, whether it's we couldn't get it out because of the satellite feed or whatever it might be, or whether we just never even opened it back to our IT in the first place. That's typically a challenge, which prevents us from all types of ROI, from all types of truck roll prevention. We also look in these OT environments and we see that very often it's individual SCADA systems that often have a singular set of attributes, meaning the product that was out there gave you these 5 fields, maybe these 500 fields, these whatever Modbus registers, and all you really get to do is see those things. You can't expand the solution. So much of what we see that's cool about IoT and valuable about IoT and delivers ROI is the fact that we unlock this stuff. We put different types of sensors, synthetic sensors, video sensors tied into our legacy OPC-UA data sets. So unlocking the attributes, the data structure, such that we can do more and just use those SCADA things as a hydration point is really something we look at when we say, what do we need to do by adding some IoT or IIoT-like capability? In those OT SCADA environments, we also see that they're using a lot of old protocols. Don't really want to judge folks for what those protocols are or what they do. They accomplished a lot. They worked very well in the world of air-gapped environments, meaning we never connected these things up to the internet in the first place. They work very well at getting data out, provided you don't try to ask them too much information at once and potentially crash the device. But ultimately, they create a real challenge if you do want to get that data out and send it anywhere, whether it's your IT, whether it's your back office, or to a cloud. So there's a real challenge that's created not only of getting at the data stably, but then securing what may be protocols that are not even IP-based running over these networks. Also in OT environments, SCADA environments, we very often will see a network, an OT network. That OT network has been critical to security to date. That OT network generally didn't let anyone in IT on it. It was a separation, that air gap we talked about. That's how we kept things secure. We're living in a world where that gap is going away. But that ultimately means that the way we manage the firewall between OT and IT, that gap is also going to change. Today, it is difficult to work with those folks. I don't know if you've done it, but they're not trying to achieve the same goals. Their goals are to maintain the security while we're trying to create new ROI. So ultimately, there's a challenge with working with that legacy firewall process. I'm very aware if we had more than 1 hour to talk, we could go into the Purdue model and all the layers within the Purdue model and essentially the one-way firewalls, so to speak, that are between them. But ultimately, if we're going to unlock this data, we have to understand how do I work with that networking team to securely unwind these things or to securely open these things in the future. One great example I have is I worked with an aerospace company one time where essentially they wanted to open the data The team that did this had a hard and fast rule in place that they could open a firewall for 15 minutes at a time. So the solution was to basically write a request every 14 minutes to reopen the firewall and have this go work around kind of the process. That's not how we want to do this, right? We want to do this the right way. We don't want to work around our processes. And the last is the challenge of OT and SCADA, and why we have to think about this so carefully, is so much of what's there is knowledge by an operator. There's no doubt operators want to do their jobs more efficiently. There's no doubt that operators want to get more out of the systems they have. They want to provide more value to the companies, but it hasn't always behooved them in the past to open these things up. More stakeholders looking at how they do business doesn't necessarily always made their jobs easier. Sometimes it's created a lot more process. So we have to make sure we address that challenge of giving a value to the operator as well in a way that doesn't make it harder for them to do their job. This is the ecosystem we're coming from. So completely different than IoT. And with this, we have data feeds, we have information we know is valuable, but we have an environment that wasn't necessarily set up to deal with the no trust. Instead, we have a world where we pretty much trust our IT network, and we trust our OT network even more. So this is a typical kind of very basic architecture that you'll see. You may have an OT device, again, the top left. That device probably is speaking to a SCADA-like solution. It's probably, we might be an OPC UA, a Modbus feed we might see in there, DNP3. Whatever that is, that data would be coming off into that SCADA-like solution. And most likely we'd be filling up what IT people would call a data store, a database. If you're a bit in the OT world, you probably would call it a historian, so to speak. So that's a very simple solution. Most often the data is one way. Not a ton of C in the SCADA in these solutions. You often just see more of the just pulling off the data and monitoring the data. If someone has decided we want to unlock that data, most likely somebody wrote a custom interchange application that knew how to get the data out, that tried to send the data to IT. So here you see this magical crossing over this firewall rule of getting the data out. And that firewall rule would live in place, but nobody could go the other way. Other devices couldn't get through. It'd be one-way exchange, most likely, of data coming out. And then somebody could build a custom app to look at that data. One way is a limitation. The ability to interact with its limitation. And then obviously there's a lot of fragility in here. And then the application or the interchange application is probably homegrown, something to maintain and keep working with the latest versions of encryption, everything else. So while this works in this trusted environment, it certainly is posing limitations for those trying to accomplish IoT connectivity, global connectivity, unlock the data in the field. There are some great things about it. You do have physical protection. Most likely you've got up gates and doors and locks. You most likely have a decent audit trail in this environment. Logs have been very important. They don't last forever, but if something goes wrong, you usually have very good logs of what exactly was happening in the field. And quite frankly, security by obscurity is not something to be ignored. The fact that you've written this homegrown application that only you or the person that used to work for you knows how to work on, that obscurity is ultimately a security value prop, as long as they did build some sort of at least encryption or some differences to it that make it harder for others to come directly into. On the other hand, there's all these challenges, the one directional, the fact that you may have the data being old that's come from the device. Most likely the legacy protocol wasn't encrypted. Most likely if somebody got behind physical protections and plugged their laptop in, they'd see wide open networks. It's possible there's no authentication, no authorization. If there is authentication, it's probably basic username and password. In a lot of cases, we saw root being used. So ultimately, there's just an environment here that is pretty hostile if it's not trusted. So if you were to provide more of an untrusted-like network, this would become a very hostile and very open environment to be taken advantage of. This is the challenge we're going into when we're trying to provide IIoT capabilities into OT and SCADA existing architectures. Again, I recognize that a Purdue model has many more layers and many more ways to address it, but ultimately there is that moment across even the Purdue model where we pop into IT, we pop into our private cloud, we may be even using cellular networks across different layers within it as well. So we have to recognize that this same activity, even in those more sophisticated environments, will probably exist along the way. So what do people do? Most folks who really want to solve this get pretty frustrated, and they do what we've seen a couple times now, which are pretty bad practices. We see a lot of practice where people take this little SCADA network, they're OT only, they come in and they have a cool little product to sell. They drop a gateway in with a SIM card they got from the local telecom down the street. And they write a little Python program that just sends all the data up to their database and their cloud application. So now you can see what's going on at the pump and those sorts of things out in the field. There's some really scary things about this, some really bad stories. If you're a bear out there looking for good data and that happens to be good device data, boy, are you licking your chops to get at this. What's going on here? This interchange application has essentially your OT network where somebody may be able to get in and go horizontal. If you're familiar with how a lot of hacking takes place, you find through a layer of security and then you look sideways. What can I talk to next that might give me more authority? So eventually a lot of these things will open up such that people can get these shell sessions. A shell session means then basically you can do all kinds of things on a local network. Where you might have intended only one direction of communication, you now have bidirectional communication because that interchange is directly accessible, meaning I can reach it from my home. Once you get behind there, then yes, you've got the problem of the data is flowing around probably unencrypted. You can Wireshark and sniff what's going on. You could even look at what credentials were being used and potentially steal them for reuse for other locations. You really have opened up yourself to a lot of risk. Because you haven't really, you really just have made an open door for you to get data out, but for others to come in. So this is a big concern when you look at what is that first step you might take to get to a connected IoT environment. How do we approach it? Well, we basically bring all of those untrusted, zero trust-like behaviors into the OT environment, but we do it using our edge, right? And basically the edge is going to provide some capabilities that are incredibly important to get that initial security. One is the OTA, the ability to update that device that's going out there, the ability actually to control that network. So you may use public network, but you could use a virtual private network across that public network. Being able to basically lock down the network, establish some trust there, and then enforce authorization, enforce authentication, enforce encryption everywhere outside. So maybe that SCADA app doesn't know how to encrypt its communication. That's okay. Nobody can get through to talk to that particular app now because we forced authentication into the front door, so to speak. Just like we talked about that enterprise side, we also can enforce the throttles. Things like brute force attempts trying to get into it, we can now enforce that practice. And ultimately, that allows us maybe to do a first step. You can notice here that perhaps we haven't gone through necessarily that hard firewall process that would go between our IT and OT networks. We might be running around a different network to do that, but at least we've put into place the best practices, the zero trust practices for getting our SCADA data out. You'll notice also as well, because of our authorization processes, we can open up the bidirectional capabilities by putting authorization of what data are you allowed to do, what are you capable of honoring. So again, this is stuff that has to get built. It has to get built by software. It's not just about an agent that pops some data out. It's much more about how do you create what is ultimately a secure edge endpoint that knows how to be the front end to these back end SCADA networks. This architecture here actually works well if you were to move through the Purdue model, basically using edges to edge to edge, can ultimately give you additional security moving through that layer, not just the network security, which often is all we find in those environments. So this is how we provide that initial step of how do we unlock that data. You can see the data is flowing back into that IoT solution. Data is not locked. The data then it goes wherever it needs to go. It needs to build data lakes that belong to you, your enterprise. It also may serve an application out of the box like intelligent assets, may help you very rapidly see this and write rules and alerts and run other actions on those devices as things come into place. So this becomes a great way to basically introduce IIoT, unlocking that SCADA data in a secure way. That's not to say we don't want to get back to actually using all of the policies in place by your organizations. We absolutely want to work within the IT/OT model, and that still works as well. So now we actually can even still put in the firewall rule, work within the IT processes to get through that transmission. But now, if you go back to trusted and even more trusted, we can still maintain that even more trusted-like environment. We know for a fact that most of the hacks that we see today aren't coming from somebody hacking the IoT system. Today, a lot of the hacks are coming from a phishing email that got through, right? So where we said our IT network was trusted, it wasn't more trusted. So we can still use this architecture. It's still incredibly valuable if we keep that edge in there through that firewall along the way. So this is kind of the model that we look to. We look to as the best practice for ultimately unlocking data, getting across networks, and then providing that application, that no-code application. All my little bears were all kind of mean big bears. This bear happens to be a little tiny bear playing in a bucket. He's not hurt. He's not trapped. He's having fun at the zoo. But that's where we want our bears to be, off alone, playing with something else, not bothering our ecosystems that we have out there. So real quick, I know we're coming up here on time. I'll quickly just talk about what we're doing in this space ourselves. Again, we're focused on big industrial industries like our building and facilities, our energy, whether it's traditional energy or more green-like energy processes, transport, moving things around, fleet tracking, and then our utilities. All of those are areas that are being leveraging our intelligent assets application. Again, this all sits on top of this security model. It unlocks this data. This provides a way that your operators in the field can interact with it. So we have a view, a dashboard view with authority, encryption, authorization that's all going on, building our audit trail of what our devices are doing, what attributes are coming off of them, and then what events and actions we take in response to that data set. So this application sits on the field. A couple examples we are using this today for water management, moving water between pits for the fracking process. I thought this was an interesting one for potential audience here. Something where they were able to define their own types of pumps, whether they were diesel or electric. They were able to monitor all types of different assets, whether it's pits or pipelines or flows. They were able to define what was their IoT architecture or what their data model was, not the SCADA solution itself saying this is the only type of data that was out there. So we have the ability to ultimately look at this data. It's incredibly important if you think about where this might be. This is where truck rolls are going all the time. The ability to know that you have a healthy system means you are not driving hundreds of miles between sites. That's the one that we have today with a lot of ROI to make sure you have a healthy network for the processes out in the field. Another interesting one, again, same application. In this case, instead of looking at pump data, pump feeds and feeds off of sensors that might be out in the remote field, in this case, we're looking at water networks, data sets about not only coming off of pumps in real time, but what the tickets might be, or the guys who are going around reading meters, whether they're live meter reads or manual meter reads, work orders. And ultimately, the exact same application was able to look across this network, this data set, and say there's a leak here. In one instance, we predicted 70 leaks when people went and looked at the locations, the actual pipes, because we knew what pipe was made of, we knew who installed it, we knew the types of pressures that have been through it for all these years, we knew what had failed in the past. We were able to find 72 leaks with 70 alerts, meaning they found more leaks at the locations we sent them to than what we said. They found multiple leaks in many locations. So same application, again, unlocking that data set, securely bringing other data sets in, and then making it actionable in the software. Another example here is solar generation. This happened to be 2 data sets coming off of the combiner boxes, the inverters, the panels themselves, to know, is the field healthy? Again, you can see out in the field, these protocols aren't necessarily secure protocols. You don't necessarily want to just open them up to the internet. So the edge sits in the field, it ingests this data, it gets the data then securely to IT, where they have a view of what's going on, where they can predict generation based upon what the sun's doing currently in this moment based upon the weather, and then find issues, right? A great example of how we have the ability to unlock that data, find ROI from that data, but do it in a secure way. With that, I really appreciate the chance to talk to everyone today. Maybe I'll stop here and just see if you want to help me with any potential questions that are out there.
First of all, Aaron, thank you so much for the presentation. I have several questions popping in my head, but I will let the participants do it. But I will kickstart with it. One, the smart meter example that you showed, where it is also predicting the data leak, is very interesting. Couple of questions based on that. One, typical installation, how long does it take for you to start proving the value back or providing back the value to the customers? Because that's always been the consideration as well as the concern, right? The security tools, as they get implemented, without processes, there is no real benefit or ROI that you can start to realize. Where it seems there is a legitimate couple of use cases where you were able to do that. And connected to that, second question is, you require very potent asset information to be able to predict what you were able to. How long did it take and what kind of process it was? So those, I thought, were interconnected questions.
Yeah, so I'm gonna do my best at the first one and remind me of the second one if I forget to get there.
Sure.
The process can be quite fast if the data feeds are there. So when we talked about if the SCADA system already exists, if the hardware is already producing the data, then actually getting the data unlocked, securely moving it back, that can be in under a few weeks, quite frankly, just because of the patterns we have in place. The solution's already there. If the hardware, the sensor feeds aren't in place already, then that's an engineering plan. Again, I don't want to underestimate what it might take to go in and add a net new data gathering tool on a railroad switch, right? That's this regulated process that Clearblade doesn't control. But if the data is already there, then it can be done quite quickly in under a month. That data comes in, there's ROI right away. You talked about the predictions. Yes, that's great. But there's ROI right away with just looking at anomalies, right? We get anomalies almost instantly based upon the last little window of time. So we can see things unexpected in that example of the water pumps very, very quickly. This is kind of like being able to look at everybody's water bill for the month and very quickly see, is it similar to last month or not? Those kinds of things. You also can see that in a water network, how much water do we charge versus how much water went out. That's non-revenue water if it leaks. All of those things fall out very quickly. The prediction model, to your second point, did take about 4 months because it did require correlating multiple data sources. I think now it would take much less time because we know a lot more about that use case and the success of the different models we tried. But if you take a generic AI use case, take a solar farm, or you take the other things, usually what you want to do is gather a lot of the data, You want to basically analyze the data enough to see what the factors or features are that drive the outcome you're after. In the case of water leaks, you're looking to see for the abnormal amount of water based upon what pipe is most likely to have leaked in the network. In a solar farm, you're looking to say, what is the amount of power the solar farm should have generated at all these different locations, the wattage, so to speak. And so you want to be able to dive right in to predict wattage based upon the solar behavior above us. So those models now, we've got some cases where we're able to generate models that start predicting within weeks, even really days, if there's a lot of data and a lot of anomalies to pull from. But in general, if you were starting fresh use case, you could think a couple months to really go through the data science activity associated with it. In the water example, that was a less than 6-month project. In the solar farm example, there also one, they did a pretty heavy A model. That was a 3-month project to do that. Both had amazing results from our perspective, outdid my expectations. The solar farm was really cool because it literally picked, we had a recent eclipse here in the US. You watch the data and the predictions around the eclipse and it nailed it. So works great, when you think about those kind of behaviors.
Sounds good. Thank you. All right. So there are a few other questions that are coming up. Paul asked, you mainly focused on securing the sensor data. When the IoT systems also include the actuators, that means making physical action happen. Does that raise any additional issues?
Sure. Almost nobody starts with actions when they're starting this process. In all honesty, it is a similar solution to this, really down to authority. You go back to, are you allowed to send that actuator that message? You go back to that edge moment where you control who can talk to that actuator. So it's quite frankly a similar process, but we usually don't introduce control, introduce action until there's a lot of trust built in the overall solution and a good understanding between the operators and what's happening. You will see some actions take place earlier in the life cycle, so some shutdown behaviors. Some of those things you will find where you're going to try to protect, not necessarily safety use cases, but you're going to try to protect the equipment itself. So you don't want the equipment to run in a damaged state. In those cases, you'll see the shutdowns be the first sort of actuator-like events that take place. You can get far more MES systems and stuff start to appear at that lower level. Not all of that gets opened up to IoT when it's said and done. Usually you're interacting from our standpoint at the optimizations and the ROI that will be done for saving the money in the remote use case, the remote monitoring case.
Paul, did that answer your question? Hopefully, if there is any other comment, please feel free to write that in the chat. Another comment over here, can you share any insights on how to effectively monitor and detect anomalous behavior within IoT devices and networks in the real time?
Yeah, so I'll at a high level talk about what we do. I believe what we do would be analogous to the common methodology. So as we get data in, we do a process called normalize the data. That means we take what was a Modbus hex register value, whatever it might be, and turn it into something that we ultimately understand as the end user. So maybe you could find the anomaly on the 0-20 millivolt sensor, but often we'd like to find the anomaly on what that millivolt sensor was reading and the conversion associated with it. So we tend to normalize the data first, and then we do pipeline it through to ultimately build an anomaly detector. So we can do multiple types of models. Anomaly detector is an easier one, where essentially we build a pipeline to bring that data through to say 1 or 2 or 3 of these things all usually work together. And when one of these goes out of norm, we ultimately generate an alert. We do that on our tool by basically having a predicted value versus an actual value, and we compare those two. So if we go out of predicted, then that's an anomaly from our perspective. That anomaly could be basically a time window. So, especially when you're talking about things that are affected with the sun, obviously you have temperatures and stuff changing throughout the day. You need your anomaly window to be kind of within an hour, so to speak, so that it's not impacted. Anomalies don't show up just for natural behaving things. So ultimately, we build that anomalous that pipeline of the data once it's normalized to then ultimately say, is this value within our expected range? Very simply, in the old world, we would have done standard deviations and stuff. Now these things have gotten a little more complex with AI models. We have partners with folks like SAS, with folks like Google. We use the open source tools ourselves as well from PyTorch and others to have models that will predict these anomalies. But when it's all said and done, it's not about the data science. It's about putting back the predicted value, or is anomaly not anomaly, back into the solution so we can take an action. Usually actions to start with are things like send me a text, send me an email. That's often where we start. But in the end, we do, start moving closer to that actuator world of turn it off, maybe close the process, turn down the volume, whatever it may be. So that's generally how we introduce it. There's always ROI up front and just getting better monitoring, but the ability then to take that data stream that's already live and then look at that data stream in real time. We call that dynamic inferencing. So as we get the data, we will inference the data. We will predict the anomaly in the real-time data stream. We do dynamic inferencing within our data stream of the IoT device. So I know that was high level. Hopefully, though, at least I said some words that are resonating with what you're seeing. You're going to understand that data, normalize it into a common structure. You'll build your anomaly pipeline, and then ultimately make that anomaly, not anomaly prediction. Potentially, you'll predict the value it should be, and then you'll drive your rules off of that to take your actions.
Cool. Sounds good. And before we come to the closure of this, and I'll give it back to Durgesh for that. One quick question, curious about AI. You mentioned about this, but is there an effort going on with generative AI helping with these complex statistical analysis solutions to be able to help new analysts or operators that are coming to the table? Because of course we are losing experience as we lose the traditional operators, or basically the people who grew up supporting these systems for a fairly long time. And when the new analyst comes, basically there is always that learning curve and training period that requires quite significant understanding of what exactly process is doing. Not to replace that expertise, but generative AI seems like a good case where there are 5 red alarms popping up. Are you able to help me with understanding what is going on in a simple English, rather than me combing through the bunch of and heap of data to be able to come to that conclusion, and at a rapid pace? Are you seeing any of these use cases that you are working on, or in demand as an industry?
Yeah, so certainly everybody's promising everything from generative AI right now, so you have to be really careful. I think, at least that's how we approach it. But we are seeing some cool things that have happened thanks to generative AI. Understanding what's in the documentation, the user manual. You don't have to read the user manual in the future, right? You just say, ask a question of the user manual, and here's the information that comes back. We're already seeing success with that. That's an area where that really reduces training time, because it means you're not going to have to know the whole manual before you get out there. It's sort of like a taxi driver used to have to know every street and every address, and now Uber just gets them there. And so you can lower that entry point. Yeah. We're seeing some pretty amazing things also as well with setting this stuff up. You can imagine when you're new to a domain, learning all the fields that are important. These generative AI tools are very easily able to go understand what a mine looks like, what these operational theaters are, what attributes are out there that matter. They've done that by parsing lots and lots of data. So you use these larger models to come back and be able to very rapidly describe your system. To me, that looks a lot like these SCADA solutions we have that do these 4 things. It's almost as if they are able to go look at all the possible SCADA systems and give you all the possible things, and then narrow it back down to what you want. We think that's really cool. And then, if I lean even forward to where we're seeing some stuff, again, we are not ones to have robots write code yet, but we do think that they can help us understand configuration better. So the fact that you have large user manuals that were written in 1984 that are, in hidden PDFs now, understanding what's in those and gleaming what registers are important, that kind of stuff, shortening that config time, shortening the amount of time it takes to screw things in. We believe there's a lot of opportunity with generative AI there as well.
Oh, good. Thank you. All right, Durgesh, giving back to you.
All right. Thank you again, Samir, for taking over. And Aaron, thank you again for your wonderful presentation. Thanks for highlighting some of the challenges we have, and also the importance of addressing the security challenges in IoT, and also the immense promise it has for all of us here in our industries. When you talked about some of the network folks that are OT security folks that are interested to make sure the security is maintained, and I'm one of those, and can really resonate with that. Great slides on architectures. Those were really awesome. So thanks again for sharing those. Also want to take this opportunity to thank all of our audience members for joining us today, for giving us your precious 1 hour of your lunchtime or before lunch or whatever that was. So thank you again. Hope to see you again. Next webinar is going to be the second Thursday of June. So follow us on the LinkedIn. I'll put the link below. Other than that, if there was any other questions, we will see you guys soon next month. Thank you.
Fantastic. Thank you, everybody.